So, is it crazy? Well, maybe, but it's about the same level of craziness as this, roughly. So, very speculative. I'm not at all, don't write this down. I mean, don't go around telling your friends that the universe is necessarily a three-brain and a bulk of higher dimensional parallel membranes. But it is one of the ideas that physicists are talking about. And if it's the case, and what these two crazy theories have in common is that in both scenarios, if they're correct, the Big Bang isn't the ultimate beginning of time. The Big Bang is just a transition, just kind of a beginning of our epoch, that what we see around us would have originated in the Big Bang, but there would have been other stuff going on before what we call the Big Bang. So there you go. These are just speculative ideas about what may have come before the Big Bang. And when I talked to Alan Guth about this, and it was, researching this book was, of course, a wonderful excuse to talk to all of these first-rate physicists and cosmologists and other people. And Alan Guth said, I think it's clearly an oversimplification to view the Big Bang as the beginning of time. So this is something that's currently undergoing a lot of study and a lot of speculation. Well, now we get to the fun stuff. We're going to talk a little bit about time travel. And, of course, when you talk about time travel, what people really want to know is, what about those pesky paradoxes killing your grandfather and all that? Because that's really where things get interesting. And it's worth separating. I mean, we have to separate this idea of future time travel from backward time travel. And the reason we have to do that is because traveling to the future is not controversial as long as you sort of understand all the terms that are involved. It's built into Einstein's theory that going into the future is as simple as going on a journey of any kind and coming back to where you started from. You have to go at some speed, because if you don't, the time differences will be negligible. Just to hammer home this point, I do have a photograph of a time traveler. Let's bring them up. All right, here we go. So this is Sergei Krikalev, a Russian astronaut. His claim to fame is that he spent more time than anybody else in Earth orbit. As you can see, more than 800 days. And of course, when you're in Earth orbit, you're moving quite quickly. So, if he had a twin brother, I don't think he does, but he would have aged 1/50th of a second less than his twin. This is just a simple fact. We know it's a prediction of Einstein's theory, and we know Einstein's theory is correct from testing it by many other methods, including, for example, sending perfectly synchronized atomic clocks, sending one of them around the world in a jetliner, keeping the other one in a laboratory, and then comparing them at the end of the trip. The disagreement between the clocks is precisely what Einstein's theory predicts, and other kinds of tests too, the kinds of experiments you can do with particle accelerators and so on. So, the problem with this, the 50th of a second, first of all, it's a very short interval of time, so it's not like your parents won't recognize you if you come back from your trip looking 1/50th of a second younger than they were expecting. So there is that. And you can also, I guess, if you want, you can quibble with the terminology, but I want to make the point that if you're younger than everybody expected you to be, it's exactly the same thing as saying you traveled into the future by that amount. Not so much into your future, which I think is almost meaningless, but into the Earth's future, or the future of the society that you left behind. I realize that's a little hard to picture because we're talking about such a short time interval. So I take a second example with a much longer interval of time. I didn't crunch the numbers myself, I just lifted them from this book by Michael Lockwood, but he imagines a journey around the Milky Way galaxy. It's a very long trip. It's about, it's more than 100,000 light years. We go with a very modest acceleration of 1g, so it won't harm your body in any way. 1g is what you're experiencing right now, it's just because of gravity. So you start off slow, but if you maintain that acceleration for a long enough period of time, you work up quite a good speed, and in fact you ultimately get quite close to the speed of light. When you get to the halfway point, you have to turn the engine around and start decelerating. At any rate, eventually you get back to where you started from. The interesting thing is, and I will omit the proof, but it comes out of Einstein's theory, you will have aged 23 years. And I mean that in the most literal sense. Hopefully it's not even that ambiguous, but really for you, if you leave at age 20, you'll come back at age 43. If you have a stack of DVDs of episodes of Lost that you were hoping to catch up with, you could watch 23 years worth of DVDs. That's what you will think has happened. But from the point of view of someone sitting on Earth, 150,000 years will have passed. And now it's a big discrepancy. So now it's not just that your parents won't recognize you, but of course they'll be dead. So, you won't have this moment of being reunited with your family. You can go to the graveyard and see where they're buried and stuff like that. And now I think it becomes a little more clear that what's happened isn't just sort of a difference in ages or a clock discrepancy, but you have traveled into the future. But I do use the terminology carefully. It's not like you've gone into your future. You still have, I mean, as far as you're concerned, nothing weird has happened to you at all. But you've come back to planet Earth, and in the newspapers, instead of being dated, well, there won't be newspapers then, believe me, but there won't be newspapers a couple of years from now. But if there were newspapers, and today they're marked 2010, you'll come back and they'll be marked 152,010, right? So you will have traveled into the Earth's future. So that's the point of this example. I've given this talk a few times, and I'm not at all, there's almost always someone who doesn't like this at all, but that's fine. You can come and talk to me later if you're unhappy. But it's still true. I want to contrast all that. By the way, I think part of the issue is that I should dig up an example that's longer than a 50th of a second, but shorter than 150,000 years, because they both seem like extremes. So if I dig around enough, maybe I'll find an example where the time discrepancy is 1 year or something like that. But I'll have to do some more research for that. Time travel into the past is a whole different kettle of fish. We don't know for sure at all that it's possible, but what we can say is that if it's possible because of the way gravity distorts space-time. So rather than being absolute, as Newton said, what we now know is that space and time can be distorted by massive objects. The sun does it a little bit, enough to deflect starlight during the solar eclipse, which is the test that confirmed Einstein's theory back in 1919. But a black hole would do it a lot more, and other exotic structures like cosmic strings and wormholes would do it a lot more. So we have these curved paths through space-time. That's kind of the starting point. And the question we want to know is, could such a path be so severely curved that it takes you back to your own past? And then, of course, what about the paradoxes? All right? So a curved path through space-time, we're all doing it every day, but it's just not curved very much, so you don't think about it. But we can certainly imagine that you're near a black hole or a cosmic string, or maybe you've gone through a wormhole, and then there seem to be a lot more possibilities. Maybe the path that you take through space-time is curved in such a way that you end up in your own past. And this is something that science fiction writers have and have not sort of dealt with. The first novel, of course, was The Time Machine by H.G. Wells. And there it's a machine that doesn't really leave the room, but just goes through time. And, of course, you can imagine going into a police call box or a phone booth or a DeLorean or something, and you come back and a lot of time has gone by. It's probably not at all going to be like that. Not at all. But it's going to be much more like a journey. So it would be something like a rocket that takes you someplace, and when you come back, you're in a different moment in space-time. And so that's it. So it's just a question of, finding a region of space-time that has the right properties, and I mean, that's the tricky part. The wormholes might not exist. Some of those other things might not exist. But if they did, then you get into this situation here.